All right, welcome. Welcome to today's QT class. I assume we all have gone through the previous classes in about 3 videos now, because we're going to be building on what we have learned so far, so good. So today we want to start with net present value, NPV. Two concepts we want to look at quickly in the course of our study today. NPV and IRR. All right, so what the idea behind this is for the NPV is built on what you have learned so far. We want to find out what the uh, present value of several cash flows are, considering the fact that at the initial point in time, mostly there was an outflow. What do we mean by that? Suppose I want to invest in a business that would cost me 500,000 at start. So that's going to be an outflow minus 500. Then at the end of each successive years, I'm going to be making, let's say, 200K, 250K, and then maybe 150K. This is the net present value of that. I need to bring the expected future values, bring them back to the present. Internet connection unstable. Please, whatever the case, if you can't hear me, just send a message on WhatsApp on the main group. I can't help it, it's raining over here. All right. Then we sum it up with this or take away. Anyway, sum up is fine. This negative value, which serves as our initial outflow. Okay, so if it is positive, we take the project. If it is negative, we reject the project. Let's just move on quickly to a question. All of this, I believe you can read on your own. NPV is positive, yeah, negative. So that's that about that. Yeah, weighted average cost of capital. I think we'll come across this at some future point in time of our study. So let's just move on to something we can relate with. Can I have somebody with example number 17 for us quickly? Anybody? Hello, I need a volunteer, please. Can I have somebody with example number 17 for us?
Okay, sir. So, suppose you are reviewing a proposal that requires an initial outlay of 2 million. You expect that the proposed investment will generate net cash flows of 0.50 million, 0.60 M, 0.75, and then minus 0.80 M, 2.5 million naira at the end of years 1 to 5 at a discount rate of 5%. Is the project worthwhile?
Beautiful. Thank you for that. So now you can see what we are referring to. So I talked about an initial outflow of cash. What amount would that be based on this question we have here? Yes, volunteers,
2 million.
the 2 million. That would be the
Yeah.
initial outflow. Then in subsequent years, we have been given the amount that will come in. So what do we need to do? We need to find the present value of all these future sums, future values that we're expecting. Then we sum it to our initial outflow. If it is a positive value, if the NPV is a positive value, we accept it. If it is a negative value, we reject the project. So that is just it basically. Now let's get to work quickly. Now I need you to get your calculators in time because I want to move very fast this afternoon. We have sorted out the basics. So let's go. I hope you have your questions. These questions opened probably on your phone or elsewhere because I'm going to be moving to the worksheet now. So you are reviewing a proposal that requires an initial outlay of 2 million. You expect the proposed investment will generate net flows of those amounts, 1 to 5. Discount rate of 5%. Is the project worthwhile? So here I am. So what do? I want to draw up a table to that effect. So I go here 0, 1, 2, 3, 4, and 5. Okay, then I might not complete this table, but I need you to help me out as we go along with it. You might want to do the same as we progress. So we want to have the cash flows here. Cash flow. Okay, so initially now I'm going to write my cash flows in a minute, please. I'm going to express my cash flows in thousands. Okay, I'm expressing my cash flows in thousands here. So this will be 2 million at the get-go. 2 million. Then 500 for year 1, 600 for year 2, 750 for year 3, 800 for year 4, and then for year 5 you're having 2,500. Now let's go back to the questions. Which is the outflows? 2 million is your outflow. So that means this is an outflow. I put it in a bracket. Now, I was also told that somewhere along the line, there's a negative 800,000 here. So that should also be placed in a bracket. This means that these are the money going out. Sometime in year 4, maybe for maintenance or to get an extension, 800,000 was also expended. I hope this is clear to us. Who does not understand what I've done so far? Nobody. Okay. So we go on. Cash flow rating. Now, what is the discount factor? Who can remind me the discount factor from the question?
5%.
5%. So how do you express this? You go 1 over 1 plus r raised to power n. Okay, so this becomes 1 over 1.05 raised to power n being your number of years. So for the first one, it is 0. Anything raised to power 0 is 1. 1 divided by 1, 1, 1 here. Are we good with that? Then subsequently, okay, this should have been, yes, 0. Then subsequently, you have to the power of 1, to the power of 2, to the power of 3, up until 5. So let me leave you to give me those values quickly. What is your discount factor to the power of -1? Quickly, give it to me, anybody? I'm waiting. Get your calculators and input for me, please. Have you left this for me to do alone? Are you there, guys?
0.95.
95, 4 decimal places, please. 95. 9524. Raised to power
0.907.
Okay, go on. Raised to power 3 now.
0.8638.
To the power 4.
0.8226.
And then to the power 5.
0.7835.
Okay, so we're done with the discount factor. So what we need to do is to find the present value of these sums. So how do we do that? Simply multiply your cash flows by the discount factor, and then this will give you a negative 2,000 still. All right, so let's go begin to multiply and give me your values. 500 times 0.9524. Hello?
476.2.
476.2.
544.2. 647.85. So we have a bracket of 658.16. One nine five eight 1958.75.
All right, so this is the present value. Now we need to get the net present value. What does that mean? We need to sum all of this together. Now, in summing up, bear in mind that this and these are negative values. So what you might want to do first is to add up this, and this. Then from the sum you get, take away this, and then take away this. So do just that and let me know what your final answer is.
I have here 968.64. That's what I have here.
968.84.
Yeah.
Come again. 9 what?
68.84.
968.84. Are you sure you did it right? I'm having a different answer here though.
Yeah.
Anyway, since both of you did since both of you added this up, I guess this is the right answer. I know. So, but whatever the case,
Careful.
is anybody talking?
I said maybe others should check.
We don't have that time, and besides, two of you have checked, so it's fine. So, since it's a positive value, we accept our MPV. It's just addition and subtraction. And if it is a negative value, the project is not worthwhile, rather. If it is positive, the project is worthwhile. If it is negative, the project is not worthwhile. So that is that about that. All right, so let's move on. What we're having here is different, but is it? Oh,
Sorry, Mr.
968.84.
It is now. We used our own as we calculated it in thousands.
Oh, okay. Yes. I remember now. Thanks for that. So,
Before you go ahead, I'm sorry, please. Did 1 over 1 plus r raised to our n gave us is what we are using to get our discount factor, right?
Exactly.
Uh,
Any other questions? No. So let's move on to the next concept here, which is the internal rate of return. Now, the internal rate of return, simply put, is just the interest rate in all of our formulas that we have been given. Okay, so in the previous classes, I have emphasized the importance of you being able to do change of subject of formula from your simple interest formula that says PRT over 100. You must be able to isolate and get for P alone, isolate and get for R alone, isolate R, and then isolate T and get the respective values. The same thing for your present value formula, which says it is or rather future value. Either ways, 1 plus R to the power minus N, or future value is present value into 1 plus R to the power of N. You must be able to manipulate this basic formula and get anything that is required of you here. So that's what this is all about, though. You can read this up on your own. Let's look at the question quickly. Let's have somebody read example number 18 for us. Let's go with volunteer.
Compute the IRR of a project which costs 10 million naira today and will provide a 15 million naira payoff 3 years from now.
Great job. So what are the concept? What are the things you are giving here? What do they mean? 10 million here is what? Anybody?
the outflow,
Which costs 10 million today?
Present value.
Present
Value.
value. Provide 15 million few years from now.
Future value.
Future value. What else? 3 years from now. What is this? This is N.
N.
Yeah, the number of years or so. So having that now, what do we need to do? First off, state your present value or future value formula. Either let me just go with the future value. Okay, future value again is present value multiplied by 1 by R raised to power what? N. Are we good with this? Feedback? So
Yes.
what do we need to isolate? We want to find the R here. All right, find the IRR. That's your internal rate of return, the interest rate there. So what do we do? All you need to do is to use your change of subject of formula concept principle to make R the subject of formula. So how do I do that again? I've done this before. I'm going to just rush through this quickly. Divide both sides by PV. So I'm going to be left with this. Then multiply both sides by the power of 1 over n raised to power 1 over n. So I'm going to be left with future value over present value into 1 to the power of n is equal to 1 plus r here. Why? Because this must have taken this out. Now I want r to stand alone. So what do? I take this plus 1 and bring it over here to become a minus 1. So my r stands alone now to be future value divided by present value raised to power 1 over n minus 1. We've done this before, so I'm not going to even ask if anybody does not understand, because I've done this in the previous videos, about 3 of them. So having this formula quickly, let's impute the things we need to impute. What is our IRR? What's our future value? Somebody give it to me. How much?
10 million. 15 million.
15 million. Just want me to write 15. The present value?
10.
10. Raised to power 1 over, what is our n? What is n again from the question?
3 years.
3 years. So we have a 1 over 3, then all of this minus 1. This is the same thing as 1.5 or 3.2. Let's input this into a calculator and give me a final answer. Somebody, please. 1.1447 minus 1, that gives you 0.1447, which is 14.47%. I hope this is clear to us, please. Feedbacks.
Yes, it's clear.
Okay, so let's look to what we have here. There we have it, 14.47%. So example 19, we have this. Somebody else read for us, please, quickly.
A project yields 1 million perpetual cash flows. If the initial investment is 20 million, what is the IRR?
Great. It yields 1 million perpetual cash flows. We talked about perpetuity the last time out, all right? A fixed sum of money paid in installments forever. Okay, so we are being told that the initial investment is 20 million. 20 million. What is the IRR? Now, again, maybe I didn't say this earlier, but it should be somewhere here. The IRR is the rate at which your NPV must always equate to 0. The internal rate of return. I'm trying to see. I don't know if this is written there because I'm not calm enough to read through. But bottom line, this is what we are referring to. Your internal rate of return is when your NPV is the rate at which your NPV always equates to 0. I'm sure the concept must have been highlighted here somewhere. All right, so let's just have that at the back of our mind. Now, looking at this question here now, a project yields 1 million perpetual cash flows and the initial investment is 20 million. Okay. What is the IRR? So what do we do? So yeah. Now we know that your NPV, the concept of NPV we treated earlier from the very first question that we had, cash flows, was that we looked at the net value. If you remember, that must have been this, where is it first? I had this one. Okay, so what we did there was simply the discounted cash inflow minus the discounted cash outflow. Do you agree with this, please? Everything we did here. Do you know this is what it is? Can I get a confirmation to that effect that this sum, NPV, is discounted cash inflow minus discounted cash inflow? I hope you understand that. Who doesn't understand?
Yes, sir, we understand. We added the inflow there.
Great. So these are the cash outflows taken away from the cash inflows, of course, discounted. Now, look at the question we have here now. Is this calculated? Yeah, look at the question we have here now. We have a project yields 1 million perpetual cash inflows. This tells us that this is our what? Inflows. The initial investment is 20 million outflow. Okay, so based on that now, we can express our NPV based on what we are given now. You know, there's no individual yearly cash inflow and outflow, so we can lump them up to say that NPV in this case is the discounted cash inflow. Please, I wouldn't want anybody to come and ask me what does this mean. No, it's discounted minus the discounted cash outflow. All right, so based on the question, what is our, now, having said that, also bear in mind that the IRR is that rate of return that we will use to discount this cash flow that will now make our NPV to be equal to 0. Remember that for you to discount a cash inflow, you need to use a rate of return, like we use 5% here. Okay, so what is that rate of return that we need to use that will make our NPV to be equal to 0 here? That's what we are trying to do in this question we have here. All right, so when you hear of IRR, just know that automatically your NPV is first and foremost not. or 0. Then you need to take your cash inflows, in this case 1 million. You know you are discounting it by what? An IRR. We don't know what it is. Yes, that's what you are looking for. But you know that IRR is the discounted rate that makes your NPV to be equal to 0. All right, so we are discounting the cash inflows by that IRR. We don't know what it is, minus discounted cash inflow. What is our cash inflow? 20. Is it 2 million or 20 million?
Inflow or outflow?
Outflow. 20 million. I am lost. Kindly signify. Are we good to go? Everybody has gotten it up until now. We should continue. No questions. Talk to me, guys.
So you say when we want to discount, it simply means we want to get the present value. Is that not?
Definitely, yes. Then when you want to compound, you want to get the future value.
Yeah.
So we can continue.
Yes.
Okay, so this is the outflow. Now I need to discount this as well. Bet. There's a bet. What is the bet here? Now, ideally, I should have done all of this. Then your IRR raised to power what here? It should have been 0. Okay, why is it 0? Because it is 0 because this is the initial point. And at the initial point, anything raised to power 0 gives you what? 1. That is why about 2,000 multiplied by 1 still give us this value here. So in the same vein, this is more or less not important here. I could have just written 1 like that, or I could have just left it blank, not writing anything there. Either way is fine. Do you understand me?
No.
All right, so I take that again. 1.47 raised to power 1 will give you will give you 1.47. Raised to power 2 will give you something higher. But what is that value raised to power 0? Can you answer my question, please? Raised to power 0 will give you what?
1.
1. Now, what is the impact or the significance of 1 when you are dividing a number by 1? Does it change the number? What is 20 million divided by 1?
20 million.
Good. So that's the point I'm trying to make, that why am I, because of the fact that this is the cash outflow at initiation, that means my N in calculating the discount factor would be 0. And that would always result to a value of 1, which has no import or significance here. That's the point I am trying to make. I hope it's clearer now.
Yes,
Is it clearer now? I need an answer, please. You are not answering. I'll just assume it's clear.
Yes.
Okay, so that is settled. Now, what do I do at this point? I want to make IRR the subject of the formula. First, I need to transfer this negative 20,000 to the other side. It becomes a positive 20,000 is equal to 20 million rather over the IRR still. Okay, so I can still put an over 1 because I want to cross multiply. It doesn't change anything. Okay, and what does this give me? My IRR times 20 million is equal to 1 million. Permit me to write it that way. Okay, then at this point, I want to divide by 20 million, both sides by 20 million, so that my IRR can now stand alone. IRR, therefore, will give you what? 1 million over 20 million will be 1 over 20. Okay, which is the same thing as 0.05, which is the same thing as your 5%. Are we clear, guys? So 5% is the IRR that we required. So this is all we have been explaining thus far. Okay. Remember that this is a perpetuity. So you're having the amount divided by your internal rate of return. Please watch the previous videos if you are not very well grounded in the concept of annuity and perpetuities. So this is settled. Okay. So we want to move on to the next concept, which is computing the IRR by linear interpolation. Okay. CIS asked this question a lot.
Excuse me, sir. Sorry, before we go, you go back to the work page? I want to screenshot where we did the working.
You have the videos, but it's fine. Here you have it. Can we continue? Hello.
Well, okay, sir. You can continue.
Okay, so here we are having the linear interpolation method. Now, as I said, CIS uses this a whole lot, and you need to be familiar with it. So to get your IRR here, what are the things you need? Look at this formula. Okay, so what is it about? You need to first find an interest rate or two interest rates that will act as your upper interest rate and the lower interest rate. Okay, then with that upper interest rate, find the NPV value. With the lower interest rate, find the NPV value. Then you do this. That lower rate plus, open a bracket, NPV using the lower rate divided by, permit me to just say the sum of the NPV at the lower rate and the NPV at the higher rate. Don't worry, I know I said some, but don't worry, you know why I said some now as we go on, because ideally, this should give you a negative value. The minus times minus will make it a plus. So let's just stick to plus, okay? Then you close that bracket, and then you have your higher rate minus your lower rate in another bracket. Let's leave this abstract and consider a question. Okay, so let's have somebody read for us example number 20 quickly. The volunteer, please read for us.
Given the following set of year-end cash flows, compute the NPV and the IRR of the project, assuming the cost of capital is 5.0%.
Okay, so okay, so that is that about that. So example 20, you have the cash flows for the year, NPV and IRR of the project. So let's get right into it. I hope you have your questions as I move away from here. So the year and the cash flows. Year, then cash flow. What's the year, the period? 0, 1, 2, and 3. Then the cash flows, negative 15,000. Let me put this in a bracket. Then 6,000, 10,000, and 2,000. Okay, so we are being told that the cost of capital is 5%. So that means that discount factor, that's what we're going to be doing at 5%. Discount factor, 5%. What do you need to do to get a discount factor? 1 over 1.05 raised to power n. Okay, so in this case already, because the n is 0, I know this will be 1. Because 1 divided by 1 will still give you 1. All right. So what I need you to do is now begin to change this value to 1, 2, 3, 4, 5 accordingly, and tell me the values you get in here. I'm waiting. Is anybody helping us?
0.9524.
0.9524.
0.9070. 0.8638.
Now that we have your discount factors, we can go ahead. Don't mind my line. Let me wipe this off. We can go right ahead now and get our present values. So this will be what here? 15,000 still. So multiply for me.
5714.4.
And this will be 1, 2, 3, 4. 90, 70. 1, 2, 3, 4. Yeah. And 2,000 times this.
1727.6.
Okay, so we have our present values. Now, what is our NPV? The sum of the discounted cash outflow and the discounted cash inflows. So you might want to start with minus 15,000, then plus all this. Tell me what you get.
1512.
1512.
1512.
Okay, 1512. Now, this is a positive value, right? This is our NPV at 5%. Now, we need to hypothetically guess an NPV rate that is about 5 to 10 marks different from what we have done, and repeat the process. Remember, I said hypothetically, okay? So that we can get a negative NPV. Are you with me? So at this point, it is hypothetical.
Please.
You say?
Recap.
Now that we are done getting our NPV at 5%, give us a positive value. We need to guess an hypothetical discount rate that we will use to run this process again so that we can get a negative NPV value. Okay, so if you increase your discount rate, if you increase your discount rate, it will be getting smaller. Your NPV will be getting smaller and getting towards 0 the more you increase it. Because of time, I will just go by 1. I'll leave you to go and work that out. Now, if you reduce your discount rate, this NPV should be increasing. You know how to decrease it. If this were to be 4 now, this becomes 1.04. Then you run it through all this process again, get a new set of values for discount factor. When you add up, you get a bigger value. But now that this is a positive value already, we need to increase our NPV so that when we run through all of this, we get a new set of discount factors. When we multiply, you should get a negative value here. The idea is to get a negative value here. Okay, so we are not particular about the exact discount factor you are going to assume. Just make sure you assume one that gives you a negative NPV. Is that clear, please? I'm asking a question. Is that clear, please, guys?
Yes, I didn't get that though. Sorry.
So, again, we use 5% here and got an NPV value of 1512. So what I want to do is I want to assume another discount factor that when I run through this, I will have a negative NPV value. Does that make sense to you now?
Yes.
Now, it's a trial and error thing, but it's always nice if you can increase it by 5 to 10% or thereabout. If this is 5, you can use 10, you can use 11. Or you can go all the way and use 15. I just want to use 11 here because of time. Okay, we don't have that time to waste. This is a timed class in quote. So now I'm using a discount factor of 11%. It means this automatically changes to 1.11 raised to power n. So at a discount factor of 11%, I know if my n is 0 again, this place will be 1. Now, please help me run through this and get a new set of discount factor values at n is 1, n is 2, n is 3. Can you do that for me quickly? Let's go. Are you still there?
I think someone is putting the answers in the chat. I guess the person that was answering for us before.
Okay.
I don't have a calculator with me, but it's saying for N1 is 0.9009
Okay,
for
just
the
help me with
first
that.
year.
9009. Okay.
Yes.
N2
0.81116.
and N13.
He has not sent the last one. Okay. 0.731. 0.0731.
0.7312.
Zero
Okay.
seven 0731. Abi? Okay, no. 731.
No. What you wrote is correct.
Yes.
Okay. So now that we have this, let's get our present value now at this 11% discount factor. So I'm going to multiply the same cash flow, 15,000, now by this discount factor at 11%. I'm going to get the same negative 15 here. So let's help me out. 6,000 by 0.9009. 1, 2, 3, 4. So what would this be? 0.9009 times 6,000.
That one is 5405.4.
And this final one here, 2,000 by this value here.
That is 1452.6.
0.4, right?
2, Abi?
So let's add up. Remember, you add this up and you take your 15 away from me. What does that give us? You guys should always come to class with your calculator so as to get familiar with it as you'll be using it in the exam.
Minus 16.2.
Negative 16.2. Now, can you see it now? So here, we had a positive NPV at 5%. Here, we are having a negative NPV at 11%. Those are the ingredients we need using the interpolation method. So what is the formula again to get your IRR using this interpolation method? So you go the lower rate plus the NPV you get at the lower rate, okay, divided by the sum of both NPV at lower rate and NPV at higher rate. Then open another bracket, then you go higher rate, the higher rate minus the lower rate. Are you with me, guys? Can I get the feedback?
Yeah, with you, sir.
All right, so what is the lower rate to use here?
The
Give it to
material
me.
says NPVL minus NPV.
It doesn't matter. Let me just
Upper.
express it this way. Don't be bothered by the letters. The lower
No,
interest
no,
rate used.
the denominator. The denominator.
It says what? Minus, right?
Yes. The
But I
material.
told you why it's going to be a plus, okay? But let's still stick to minus now. Let's just stick to minus for now, okay? But you see that it's going to be a plus. So let's go. What's the lower rate again? I need to hear from you, please.
5%.
So I put my 5 plus. What is the NPV at that lower rate?
1512.
Okay, divided by 1512 minus, Abi. So what's the NPV at the higher rate now?
Minus 16.
Another minus 16.2. Close your bracket. Then the higher rate was 11. The lower rate was 5. Now, when you have something like this in this, what is minus times minus in mathematics?
Plus.
That's why I would have just gone with plus and avoid all this unnecessary work when you can. Are you with me? So moving on, this becomes 5 plus 1512. What does this give you? 1528.2. Then multiplied by what? 6. So do this for me quickly. 1512 divided by this value multiplied by 6, then you add 5 to it. That's the value of your IRR. What does that give us? Is anybody helping with the answer?
0.936. 10.936.
10.9364. Or you can just say 10.94%. Are we clear? 10.94%. Now notice that from the very get-go, I skipped introducing my percentage sign here and here. It is to avoid confusion. So when you are done, just put it back in your answer and you should be fine. So where was that? Yeah. So this is all we have tried to do. Okay, so you're having discount factor at 10%. You can try it out here as well. Okay, you are probably going to still get a positive value. We need to get a negative value. That's why we went directly to 5 and 11% respectively. Input all your values. You have all of that. You just read this up on your own and we should be fine. So we have some explanations here and the relationship between them. the NPV and IRR methods rank two projects differently depending on the size of the investment. So you have a case below. By the NPV rule, we choose project A. Why are we using project A using NPV? It has a greater NPV than project B. But by the NPV rule, we choose project A, and by the IRR rule, we choose project B. Why are we choosing project B? It has a greater IRR than project B. So the convention is to use NPV rule when the two methods are inconsistent. So at all point in time, the NPV trumps the IRR method. So I think that about that. We move on to the last concept here before we call it a day, the accounting rate of return. Can I have somebody read for us, please? Starting from here. Quickly, we have 7 minutes to the end of the class, please. Please, can we have volunteers, please?
A firm is considering investment on a project with an initial investment of 1 million naira and a life of 5 years. The profits after tax and depreciation generated by the project are estimated to be as follows. Year one.
Sorry, I said read from here. So not the question. I just wanted to get some concepts from here.
The accounting rate of return ARR. The accounting rate of return ARR is also known as the average rate of return. The ratio, however, does not take into account the concept of time value of money. The ARR provides a quick estimate and is calculated as follows. ARR is equal to average profits over average investment.
Great. Average profit over average investment. As you know what average profit is. It's the same way you calculate your averages. So let's go. And then the same thing with the investment. So you are reading example number 21.
A firm is considering investment on a project with an initial investment of 1 million naira and a life of 5 years. The profits after tax and depreciation generated by the project are estimated to be as follows. Year one, 250 cash flows. Year two, 150. Year three, 200. Year four, 120. Year five, 280.
Okay, so we are trying to get the accounting rate of return or the average rate of return now. So how do we calculate that? First, we need to find the average profit. So what is the average profit here? You sum all of this up and divide by what? Average. 1, 2, 3, 4, 5. Divide by 5. Are you clear with that, please? So that will be 250 plus 150 plus 200. This divided by 5. And give us a. And again, we need to find the average investment. Our average investment we put in. I hope you are still with me. So tell us, what is the average profit here? Can you still hear me, guys?
Yes, sir, we are with you.
Okay, so I'm waiting. Get the average here for me so that I can impute the value.
That's 200.
Sorry?
1,000 over 5. That's 200. So that's
200.
1,000 over 5.
Now, so we got 200 here as the what? Average profit. So I take the average profit and divide it by average investment of 1,000 here, or rather 1 billion. So give or take, we're still doing the same thing. This will be what? 2 over 10 or 0.2 or 20%. I hope that's clear to us. So that's that about that. Okay, so we have revision questions. Now, based on, I want to urge you to just go watch the videos again. It's about 4 videos now. We've come to the end of the class. Then you try out these questions yourselves. The ones you now have issues with, you can just chat me up during the course of the week, and then I can provide clarity on it. In the next class, we will just move on to chapter. Okay, you have answers here that follow as well. We move on to the next chapter, so that we can finish on time before CIS starts bombarding you with their revision classes. All right. Are there questions for us to look at before we go? Any question on what we have considered thus far?
Sir, please go back to what you just saw now, so we can make this screenshot.
Yeah. I'm there.
I just wanted to see it. I didn't write something before. Thank you.
Okay, so please just watch the videos and then we should be fine. If we come to the end of the class, let me.
Sorry, sir. You did a bracket of 200. Hope it doesn't mean that it will be minus that way.
No. I just know it doesn't. It's not a minus. I don't want you confusing it with the 5 that was on top of it. Okay,
Okay.
so it's not a minus. Yes.
Okay.
So
So just
you call
like
it a
saying
day.
200 over 100.
That would be 200 over 1,000, right?
Is it 1,000 or is it not 100?
That
Oh,
was
okay.
1,000. 200 over 1,000. Please check to be sure.